Hello everyone, welcome back again to this new video. Here we shall discuss about variation of molar conductivity with concentration. In our previous video, we learned about variation of conductivity with concentration. In this case, we'll be discussing both strong electrolyte and weak electrolyte. But before that, let's have a discussion about the molar conductivity. As we know, molar conductivity is equal to kappa by C. That is conductivity depend upon the concentration. Conductivity by concentration. Also, we may write it as lambda m equal to kappa into V. That is, it depends upon the volume. Now, in this case about strong electrolyte and weak electrolyte, we will check how it varies with concentration or with volume. As we know, on dilution, concentration decreases and volume increases. First of all, let us consider the example of a strong electrolyte. In our previous videos, we learned about strong electrolyte. Strong electrolyte are those electrolytes which dissociate all their ions in the solution. For example, potassium chloride, sodium chloride, ammonium chloride, etc. It means at any concentration, they releases all their ions. Now on dilution, what happens? Let's see. On dilution, the volume basically increases and the concentration decreases. So it is obvious from the equations that if the volume increases, molar conductivity will also increase, because you see concentration decreases and molar conductivity increases. It goes on decreasing, then this value will rise. Similarly, here also we can check if this increases, then this one will decrease. Conductivity will definitely decrease, as we already learned in our previous video. So molar conductivity will rise. So for any strong electrolyte, what happens? If volume increases, concentration decreases. So if you look at the graph now, if you check, then you can see concentration values are here, let us say. Then it is found from the experiment that the square root of concentration, if it is plot on x-axis, and lambda m if it is plot on y-axis, then what is observed that with decrease in concentration, the molar conductivity value increases. So what happens if we go on dilution gradually? A certain stage will be reached when there will be no further increase in the molar conductivity value. I hope you have understood about this point. Students, mind it once again. If we go on dilution, that is, if we go on decreasing the concentration, what will happen? Molar conductivity also goes on increasing. But the problem is that what? There is a stage which will be arrived or reached when the concentration will approach almost zero. It means if you say about the value of square root of concentration, that is 0.01, 0.001, 0.00001, this way. So a stage will reach when the value of concentration will be almost such, that is, the dilution is too excessive. Or at this stage we can say that the concentration value almost approaches zero. And as already we have mentioned that on goes on decreasing the concentration, the molar conductivity increases. So this molar conductivity value at this stage will be fixed in the sense there will be no further increase on this value. So it will attain a certain limit, and that's why there is no further rise. So this limiting value of molar conductivity is called limiting molar conductivity. It is called limiting molar conductivity, or also known as molar conductivity at infinite dilution. Infinite dilution means there is no further possibility of getting lambda m. So lambda m naught may also be written as lambda m infinity. So molar conductivity at infinite dilution. This is about strong electrolyte. As we have seen, a straight line is obtained for strong electrolyte in the graph. So from the graph, we can write an equation that lambda m is equal to, that is y equal to mx plus c. So if you consider it as y, lambda m is equal to mx. So the slope is negative. Let's say the slope is a. X, what is x here? Root over c. And what is the intercept? Plus lambda m naught. So this is the equation. The slope is m, x-axis is root over c, and the intercept is lambda m naught. So for strong electrolyte, by using the graph or from the experiment, we can find out the value of lambda m naught, that is limiting molar conductivity or molar conductivity at infinite dilution. But what is the problem with weak electrolytes? As we already discussed, weak electrolytes do not ionize all their ions or do not undergo completely dissociation. That is why what happens on dilution, although the volume rise, definitely lambda m value will also rise. But the problem is that straight line is obtained in case of strong electrolyte, which is not possible in this case, because in this case dissociation is not completed, and that is why what happened, instead of getting a straight line we may get a curve, because it is very difficult to say that at what stage the dissociation will be completed, and that's why it is very difficult to find out the value of lambda m naught from the graph for weak electrolytes. This one we must have to remember. So these are the two different cases for strong electrolyte and weak electrolyte. So we can say that lambda m naught value can be possible for strong electrolyte from the experiment or from the graph. But from the graph, it is very difficult to find out the lambda m naught value. So there is another way to calculate the value of lambda m naught or lambda m infinity, about which I will discuss in my next video. If you find any doubt or problem, you can inbox me. Thank you very much for today.